Mm. 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 2 o'clock. 2 o'clock.
Okay, 2 o'clock.
2 o'clock. 2 o'clock.
Let me see the now that was your info. No, don't worry. Mama mistaken me in a number. No, don't worry. My baby. No, don't worry.
Mm.
No, don't worry,
Mm.
Uncle.
Mm.
19 over 40.
Mm.
Mm. Instruction for the river. Virginia comprehension. It is like this. Filter. Nani
Mm.
for the very thick. Which of the case are coming? What happened? What happened to you?
Hello?
Hello, yes. I have it with you now.
Okay.
Okay.
Okay. So now, I want you to look at that. Look at it very well.
Okay.
I'm trying to see to make sure. Okay, let me off my video. I don't want it to be distracting us. Okay, now, what you have on your screen is now the from this layout. Okay, you put it into this form. Then when you finish, when you draw your water network, you're going to get this. Is that understood?
Okay.
When you finish drawing your network, you know what we talked about yesterday. After description, water demand, everything. The end of the day is that you come and draw your distribution. How does you want the water to go? Having the road network handy.
Okay.
So
yes.
when I ask you to draw, I'm giving you expo now. Expo now in quotes. When you finish your drawing, this is what you should come up with. When I give you this now, as a water engineer, and ask you to draw, your output should be this. Okay? All you need to do is just look at these two. You see
Sorry,
that.
what I'm still viewing on the screen, I'm still seeing the Excel sheet.
Okay.
Yes.
Okay.
That's a check of service pressure in notes.
Can you see it now?
Okay. Yeah.
Go down. Can we continue now?
Yes, we can continue.
Okay, now see here. Let me rotate this thing again. You see, if you lay a pipe here now, or let me use annotate. If you're asked to draw this pipe now, you pick up a line. For instance, you draw the pipe. Your pipeline will go like this. Go like this. Go like this. Are you with me?
Yes.
You know, it's following the road corridor. You understand me?
Yes.
So that you don't have to enter somebody's property.
Okay.
That's how to follow. To come down here. Are you watching me?
Yeah, I'm watching.
When it comes here, it branches this way. When it comes here, it branches this way. Then this one also branches this way. Then this one branches here. When it goes to here, it will branch into two places. And so on and so forth. So this is what you get. Let me drop my annotation. This is what you get. You get something like this. Sorry. Can you see what I just drew?
Yes.
Okay, let me clean this. Erase or clear. So now you can see it now.
Yes.
So if I ask you to draw this, you can draw it.
Yes, I can.
Good. So if you draw this now look at station point 1. Let me use spotlight. Look at point storage tank to point 1. That becomes a section. Point 1 to point 2. That becomes a section of pipe. A section. This section can be street, it can be long street, it can be, it can be not necessarily length of pipe, but you just represent a section like a street. Then here now is 1 to 4 is a section, 4 to 5 is a section, 4 to 8 is another section, 4 to 3 is a section, 8 to 9 is a section, 9 to 10 is a section, 9 to 12 is a section, 8 to 7 is a section. Then at 7, it will divide into 2, into 7 to 11, and then 7 to 6. Then at 6, it will continue to 6 to what? 13. Okay?
Okay.
Those are length of street, and they can also be looked at length of pipe. So in designing, we're going to design those sections, the pipe section, the pipe in those sections, by knowing the demand in each of the succeeding nodes. In other words, if I want to know the demand in all these places, I will just put the demand of all the people using this water along this, people are living along this street. I just put the demand in 13. You get the point?
Okay. Yes.
All the people living along between 9 and 12, I'll put their demand inside 12.
Okay.
Just like what you have here. You see, all these houses along this 6 to 13, their demand will now be put into 13. So instead of me drawing small short lines connecting the houses, there's no point because this is a model. I'll just leave it the way it is, but I'll aggregate their water demand, multiply by number of houses, the value I get becomes the value I'll put here. I will now in turn use that value and do what we did yesterday by estimating the size of this pipe that's carrying the water.
Okay.
So to achieve that, you need to call out this into an Excel format like this by saying storage tank to point 1, the length is 120 meters. Then the discharge we don't know, the slope we don't know, the diameter we don't know. So in other words, we're going to get those 3 first parameters. All these empty boxes, we're going to fill them. Once we're able to fill them, that becomes our value we use to go and do our design. So we have point storage tank to point 1. The length of the pipe is 120 meters. From point 1 to point 2, the length is 60 meters. Are you with me?
Okay.
And so on and so forth. Please, at any point you have a question.
The first question, please.
Good.
The length of the pipes is from our physical
measurements. Yes, sir. Yes,
measurements.
Sir. Yes. If it's a drawing, you use your AutoCAD tools and measure out the length. That's why I keep saying you need a layout.
That's a drawing that is to scale.
Good question. A drawing that is to scale. If the drawing is not to scale, later on ask me, I'll show you how to do scaling.
Okay.
To scale. Of course, do you remember there's no any professional drawing must have scale?
Yes. Any professional experience, but you know the system in Nigeria, some of the things they might not give to the right person to.
If it's not to scale, you do what we call georeferencing.
Georeferencing.
If I want to, let me just tell you what georeferencing is all about. If I want to get the scale of any drawing, I only have to go physically and measure 3 points.
Okay.
If I measure 3 points in a land, I'll come and find their equivalent length in the map. So I will now develop an algorithm. In other words, if I got 100 meters on ground and in the map I'm getting 10 meters, it means the scale is 1:10.
Okay.
If I measure 500 meters on the ground and I come to my drawing and I'm seeing 5 cm, it means that drawing is 5 cm over 500 cm. I'll divide numerator, denominator. Anything I get, that becomes the scale. So you find out that if you give any value and I multiply with that scale, it will give me the new value.
Okay.
So now this is what you're going to write. If you write this, your job now will be to find these 3 first parameters. You see these first 3 parameters. You need to find them.
Okay.
Now, whiteboard. What do I want to show you again? There are 4 things you need. You need 4 parameters. 4 parameters to design a water reticulation system. What are those parameters? Number 1 parameter you need. The first parameter is the pipe parameters. The second one is the node parameters. Under the pipe parameters, you need to have the length of pipe and after the length, you also need the diameter. Are you with me?
Yeah, okay, yes.
Then for the node parameters, you need two things. The first thing is the flow. Remember yesterday I told you that flow can also be called demand.
Yes.
It can also be called discharge.
Yes.
Then the second thing you need, is the elevation. Please, I want you to master these 4.
Okay.
If you look at this drawing, are you seeing the drawing?
Yes.
The 2 parameters you can see in this drawing are elevation and then the length of the pipe, or let me use the table. You can see the elevation here. The elevation here, can you see it?
Yes, I can see it.
And then the length of the pipe. So our job is now to find the remaining 2, which is the discharge and the diameter of the pipe. I told you yesterday that the most important thing we need to do in water reticulation is just to find the pipe sizes.
Yes.
Somebody will say, how about the pump? Yes, the pump is very easy to get. You don't have problem with the pump. Okay? The pump is easy to get. Oh, how about the storage tank? The storage tank is easy, and I can fabricate that one. But if you didn't get the pipe sizing well, you're in big trouble.
Mm.
If the pipe sizing is small, water will not flow. If it's too much, it will cost a lot and the pressure will drop.
Mm.
Are you with me?
Yes.
So very, very important. So remember the 2 parameters I say you need. Pipe parameters and node parameters.
Yes, pipe parameters.
In pipe, what do you need in pipe?
In pipe, I need the length of the pipe and diameter.
In node, okay?
Node, I need the flow and the elevation.
So how do you get the flow? I showed you yesterday.
Yes. Well, from the demand.
Good.
Once I can get the demand,
good.
I can get the flow.
Then the other one is then from that demand and flow, you now go to your chart and then get the diameter.
Diameter, yes.
So once you get the diameter, you draw your network, isn't it? And
yes.
then assign those diameter to them and detail them.
Yes.
And that will be the all.
Yes. Okay.
Ask yourself if you have one.
Yeah, but in this case, how do I get my demand?
Which one?
In this case now that I'm trying to do.
Now the demand you need to do now is you first of all get the demand for one house, and then you ask yourself how many houses are in each street. That becomes the demand for that node in that street.
Okay.
For instance, now we can try to say that each house is here. What do we talk about? This house is here now.
Yes.
What kind of house can we call them?
We can just call them a duplexes.
Duplexes. How many people are we designing for in each duplex?
Yeah, an average of 10 people.
No.
Okay.
In Africa, we do.
Okay, an average duplexes has, let's say, 4 rooms.
Mm-hmm.
Yeah, like, okay, 3 rooms and the mate's room in ground floor.
Mm-hmm.
So you have the family of 5 up, then you have the mates living approximately 10.
Okay, 10. Okay, let's use 10.
Okay.
So now, each duplex now, it has 10 occupants.
Yes,
And
that's
each of the occupants, we are giving them 100 liters per person per day.
yes.
And we are giving a safety factor of 2. Let's use safety factor of 2 for just to make it easy for us to calculate. Remember,
So
between
we have
1.3 and 2.3.
10 multiplied by 102. That's peak factor of 2. Okay. Yes.
If we convert it to seconds, it will be this number multiplied by divided by 2000. Are you with me?
Yes.
So that will be 2000 divided by what? 86400.
This is 400.
0.23. liters per second, isn't it?
Yes, 0.2 liters per second.
Okay.
So
Now, how many houses? Good. Now we now say how many houses are in streets. I'll name the street according to the pipe passing through the street. Are you with me?
yes.
Street 6 to 13. How many houses are there? Can you count it? I'll tell you.
Let me. Okay. 6 to 13. So
Sorry?
go back to the drawing. Okay. I should. Okay, 6 to 13, right?
6 to
So we
13,
have.
yeah, on both sides of the
We have.
road.
Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 23 houses.
Eh?
23 houses.
So it means the flow or the demand of the street becomes 23 houses times
Multiplied by
0.23.
liter per second.
Did you agree?
Yes.
I don't think I'm right. 23 times 0.023.
That's 5 point.
No, I went and said 2.3. That's 0.023. That's 0.529. 0.53, sorry.
Okay, 0.5. Okay, okay. Let me see. 2000 by 86,400. Okay, 0.023 multiplied by 23. Okay, so you have 0.5
Yes.
meters per second.
That becomes that will become the value
Our flow.
in node 13. So I'll go
Okay.
to node 13 and put it there. Let me see if I have Excel of this.
Okay.
Great, open Excel so that we can be putting.
Hello? Hello?
Hello.
Sorry, you went off. You said I should open Excel?
Yes, I'm thinking maybe to make you understand it further, we'll come here, we'll say node 6 to 13.
Okay. Okay.
Are you seeing my screen?
Okay. I'm on this. Let me go back. I'm on where I am now is where you are noting, where you are writing on the whiteboard.
You can see my Excel now, I guess.
Okay, now I'm here to see Excel.
I'm I'm coming.
Okay.
Yeah. Okay. Now you can see it.
Yeah, I can see it now. Mm.
6 to
Okay.
13. The flow we just got now is
0.5 liter per second. Quantitative flow, okay. 5.3 to nanogram.
Can you see it?
Yes.
Now, what do you think will be the diameter now? To get the
Okay,
diameter, I'll go to my chart.
chart.
God bless you,
Okay.
sir. You're following. Which chart? PVC, Abi?
Yeah, okay, yes. PVD is that's 0.1.
1.
Hey, sorry, before we go ahead, this PVC, can I use it the same thing with PPR?
PPR is even better. PPR
Because
is
it's
even
PPR we
better.
work with. It's PPR we work with. PPR
No,
and multi-layer pipes.
PPR is better. Is more efficient. So PPR should even be 0.05.
Okay, 0.05.
Yes, that means if you're using 0.1, you're on the part of safety. Are you with me?
Okay.
This is the limit. Some PPR pipes are in the range of 0.01. In fact, they are very smooth.
Yes, the flow. Like the one
No, the pipe material. No, we're not talking about the flow now. The pipe material.
The pipe materials, yes. Because the one I have that I have the franchise, it's I have the technical details, so it's very
efficient.
Excellent.
It's very efficient.
Excellent, yes. So, but how do we get our gradients?
Our gradient now is site now. Our guest now, you go to elevation.
Okay, elevation, okay.
That reminds me. So I have to add it in that Excel. Let me add gradient, okay?
Okay.
Insert. Let me not even call it gradient. Let me call it what it is. Slope. Now, if you go back to that chart now, can you see the chart?
I can see the chart.
Now, point 6. The pipe is coming from 6.6 and ending in point 13. The beginning of the street is 6. The end of the street is 13.
Okay, let me go back to my. Okay, I'm there now. Yes.
So point 6, the elevation is 261. Point 13. Point 13, the elevation is 252.
That's from the drawing,
from the
this thing, right?
Table.
Table. Okay.
At point 13, it is 252, sorry. From what your surveyor got.
Yes, 252.
And then the other one is 252.
0.6 is 261.
The other one is 261. So the elevation difference now is 261 minus 252. That's about 9. Are we together?
Yes.
So 9. Then 9 now. Divide by the length of 6 to 7, 6 to 13. So look at the charts. Look at mine.
Okay. Yeah, I'm on the charts. I opened. Okay, I should look at yours.
Not the chart, sorry, the table. See, 6 to 13, 6 to 13. The length of the pipe is 210.
Yes, 6 to 13.
Yes. Section 6 to 13.
Okay, we'll pick that. Okay, we are going to pick that point 13.
No, the length of that street. What is the length of the street? Remember, you took the point from the beginning of the street and end of the street. So it means that's your x axis. That's your y-axis, sorry, your vertical axis. So the next thing now is the horizontal axis. You know, remember slope is vertical over horizontal, remember?
Yes, vertical over horizontal.
So if you want to know the slope of your road in your street, go to the beginning of the street, take your elevation. Go to the end of the street, take your elevation. Divide the elevation difference by the length of the street. That gives you the slope of the street. True or false?
Okay, true. So which means I will now use this over 210, right?
Yeah, over 210. Yeah, thank you. That becomes the slope. So for each of them, that's what you'll be doing to get the slope.
Okay. So I have okay. My slope is 0.0443.
Sorry?
0.0443. So if I should multiply it by 10, right?
Mm-hmm.
By 10, so I will have 0.4 from my drawing, right?
Mm-hmm.
Am I correct?
Mm-hmm.
Okay, 0.4, and I have the flow rate of 0.53. So 0.4. So my pipe diameter will be 200.
Sorry?
My pipe diameter will be 200.
It can't be top 200 though. Hey, it's too much.
Oh, okay, because it's 0.4, right? And I have my, sorry, my flow rate is 0.53, okay, 0.53. 0.53. Is my flow rate correct?
0.53, yeah?
Yes, because
okay, I remember something. There's something I didn't tell you. If the flow rate is less than 1, you use the value for 1. Sorry, I didn't tell you that.
Okay. So I have 0.4. Okay, so which means my pipe size will be 100 mm.
Thank you. So you have designed that section. So you go to that table and impute it.
Okay. So that's 100. Diameter is now 100 mm. So go to my. Okay.
So now you have to design the next section. Can you see my chart?
Okay, I should go back to the chart, right?
Yeah, the drawing, sorry.
Drawing, okay.
Yeah.
Okay, we are picking the next point.
The next point we are going to pick now is 0.6. We have designed 0.13.
Sorry, should I be on the screen, or I should just go to the chat?
Look at my screen. What are you seeing on my screen? The distribution network.
Yeah, I'm still seeing the Excel.
Okay. I understand. Don't worry. What do you see now?
Yes, I can see the drawing.
Now, we'll design it from the lowest point to the highest point. That's the rule.
Yes, okay. Sorry, you said from the lowest point to the highest point, right?
Yes.
Okay.
Following the tree, we'll be doing like a tree calculation. I don't know what you guys call it in mechanical engineering.
Yeah.
But there must be a name, but watch what we're going to do.
Okay.
Now, we've designed the pipe size of 0.6 to 13. We have found the demand at 13. Now, we're going to find the demand at 6. To find the demand at 6, we need to ask ourselves, how many houses are between 7 and 6?
Okay.
So
I think looking at you are looking at 7 to 6 now.
Yes.
Okay. 7 to 6. Okay. 7 to 6. Okay. Okay, I'm there now. So we have okay, now this 7 to 6. Okay, 7 to 6. Okay, it's just one side of the road. So we have like 1, 2, 3, 4. Let me check the okay.
If you see empty space, you can assume there will be a future development there. You can count it if there's an empty space. But
Okay, so
that's at your own description. At your own discretion.
Okay, which is just be 6 to 7. Okay.
Okay.
6 to 7 is
and you multiply by the value for 1. The value for 1 is 0.023.
Okay, so we have 1, 2, 3, 4. So I will make it 8.
Good.
8 houses. 8 houses. So 8 multiply by, I assume each house has 10, just the way 10 multiply by 10, then multiply by the man per capita.
Yeah.
That's 100. Then the peak factor, that's 0. My peak factor is 2.0.
2.0.
2.0. Okay. I have 8 multiplied by 10 times 100. So I have 16,000. It should be 16,000 liter per day.
How many?
No, I have 16,000 liter per day. All over 400. 400. So which gives me 0.2. Or must I take it up to 2 decimal place? Because I have 219, so 0.19, so approximately 0.2 liter per second. 2 liter per second. Wow. 0.2 liter per second. 10 per person, 10 per person, 10 multiplied by. Okay, I have 0.2 liter per second, so that's node. Which node will it be now? It will be node. Which node? Node 13. It should not be node 7. Is it node 7 or node 6? Node 6. Node 6. Node 6 will be 0.2 liter per second. So for me to get my slope, liter per second, for me to get my slope will now be 10. 0.79261. 261. 7. 661. And 1. 6, 7. So, okay. Spent. Oh, there's a problem. Maybe 30. Seems it's off. No, you'll come back. Maybe just 10 minutes. No, please. You talk to Mark. No, it's not on mine. Something. I call you an integer. Because the breeze is blowing, that's why it will be like a what? They'll bring light. But this kind of office, they're knowing that they should make one window for here so that air could be passed. 16. So you open to get fresh air. 10. You need to consider people. Response. That's note 6. We're going to use note 6. If you use note 6 from the elevation here. Elevation so this point 667. I have question. Yes, you know what? Street 6. You're being it. Is your this bro? It's just you. One minute, see the finger. Six. He has gone off. He has gone off.
Hello?
Okay, you're back.
I didn't went off. I off my microphone. I mistakenly offed it.
Okay, I've been trying to reach you, but so since I didn't hear from you, I now
No. Sorry, forgive me.
Okay, no problem.
Now, you have gotten note 6 correctly, 0.2.
0.2, yes, but
you will not write 0.2 in note 6 because note 6 has precedence. No, antecedents. Antecedent, yeah. He has, in other words, what you have in note 6, what you got now is a base demand, what we call base demand. But that is not the actual flow. So you need to add 0.2 plus what you got in note 13. That will be the value you write for note 6.
Okay, because I picked my point from the lowest point, right?
No, because note 6 is flowing downstream.
Okay.
Now, in other words, the value you got is just the value of the houses that are directly linked to note 6. But note 6 has to allow 0.5 to pass through him.
Okay.
I want to use a layman's language to make you understand it, and that's the best thing, because this is the most important thing you need to understand. Once you understand it, my job is done.
Okay.
So now what you got now are 8 houses that are connected to node 6.
Yes.
Now, but node 6 is also feeding another 23 houses that are downstream. So the total value of node 6 is going to be 0.2 plus 0.53.
Okay.
So write it.
Okay.
So we're talking about 7 to 6, yeah? And that will be at 0.6. So 0.6 will now be 0.2 plus 0.53.
0.73.
Oh. Should I do it? Sorry, the slope. You know how to calculate the slope? The slope can be anything. Let's say 0.5. You can calculate it. I don't know what it is, but no need to. I don't want to waste my time.
Yeah. Although I tried to calculate the way you did for 6 to 13.
Yeah.
That's for
what did you get? What did you get?
Yes, I found out that the way you explained it the other time, we went to the table, then we checked the elevation points at 7 and 6, right?
Yes.
So the difference, but
it's almost zero. That means a flat land.
So that was again. I now went to the net of pipe, since we are picking the point.
You know what you do? If it's a flat land, you give him a minimum slope. Okay.
Okay, minimum slope. Okay.
You give it a minimum slope. But for now, let us use the slope of the succeeding one, which is 0.4. So let's use 0.4.
Okay.
What you got there is telling you that that's a flat land.
Okay.
So that means you're going to lose. So be on the lookout when we're doing the simulation. Be on the lookout that there might be pressure losses there.
Okay.
Because the land is flat, there might be losses. The losses there will be high. Sorry.
Okay. So we use the previous slope. 0.4. So for my ground 0.4. Okay. So 1. Oh, we're still using the same diameter.
What are you doing now?
I'm checking the graph.
Okay.
Chart, sorry.
Okay, what do you get? What did you get?
Which is, you are using the same diameter.
Like 100 mm.
100 mm, yes.
That's fair now.
Okay.
Now. It's fair. It mustn't change in short interval, okay?
Okay.
I mean, street A and street B, there might not be any difference. It's as good as it's a continuous street.
Okay. 100 mm. Okay. So
the next one now, before you calculate for node 7, you need to get node 13. You know why?
Okay, node 13?
No, node 11. Before you calculate before you get node 7, because node 7 is like a father that has 2 children.
Okay, just
so
like
the value of node 7 is going to be the value of node 6 and the value of node 11. Okay. And then if there's any other value that he himself is feeding, you also add it. In other words, if there are houses that are lying between 7 and 8, you now add it. So it becomes 3 variables. Are you with me?
Okay, for node 11 or 7?
For node 7.
Okay, so we're adding 8 again.
Node 7 is node 6 plus node 11. So because of that, we are going to treat 6 to 7 first. 6 to 11 first, sorry. We are going to treat node 11 first. So let's go to node 11.
Okay.
I go to node 11.
Okay.
Are you seeing my Excel?
Yes, I'm seeing your Excel. 7 to 11. Okay. 7 to 11.
You do the slope thing. I don't know what you get in the slope. I don't want to do it. It's easy.
Okay.
Slope is height over horizontal, vertical over horizontal, which is the spot height, the coordinate of the 2 points divided by the horizontal distance.
Horizontal distance. Okay.
So That one is
Okay.
is self-explanatory.
So for the number of houses now
How many?
between notes
How many?
note 11 and so we have
Remember to add safety, to add extra if need be. Assuming the shape of the house is bigger than our duplex.
okay, come let me check. Let me still go back.
Just use common.
Because I have to go back to the drawing.
Just use common sense.
Let's okay.
If the house look bigger, it might be semi-detached.
Okay. Okay. So let me see. Between 7 and 11, right?
Yes.
1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, if I have 1, 2, 3, 4, 5, let me see 10. 10 plus 2, 3, 4, 5, 6. 10 plus.
Are you still doing those 7 to 8 to 11?
Yes, I'm counting the houses.
Okay, go on.
Yes, I'm counting the houses there. So we have 10 plus 1, 2, 3, 4. Okay, let me make it 15 houses.
Oh yeah, now instead of going through 15 times 100 times this, why not just go for the value of one house?
Okay.
Since you already have the value of one house is 0.03.
Yes. One of one house is 10 multiplied by 100,
which is 0.023.
20. Yes, 0.23. Okay.
So you just multiply by 15 by 0.23. 0.023.
Okay.
It's the same thing now.
Yes, the same thing. Yes, multiplied by 15. Yes, the same thing. So I have okay. The flow rate is multiplied by 0.023. 0.023 multiplied by 15. 0.23 times 15. Okay, so I have 0.35. 0.35 liter per second.
Good. Let's write it. So, do we need to design for the pipe?
Yes, we need to design for the pipe. We just use the slope of 0.4 to get the pipe. Let me go to my graph. 0.35. Okay. Oh, this is it. Okay. I'll still get out the same thing.
Good. I write it now.
Okay. Diameter is equals to 100 millimeter. Okay.
Now, let's look at points 8 to 7. Are there houses there?
Point 8 to 7.
I can see 4 houses.
Okay, yes. So we now make it 8 houses.
Can we just make it 10 to make life easy for us?
10.
If we make it 10, the value will now be 0.223.
So which is we've gotten for node 11, right? So now we're looking for node 7.
Yes.
That's streets.
Yes.
7 to 8.
Yes.
Okay, streets 7 to 8. Okay. So we have 8 houses. Okay, so we said we should make it 10 houses, right?
For ease of calculation. So that the value will now be 10 times 0.023, which will give us 0.23.
23 multiplied by, okay, yes, 0.23.
Now, are you going to write 0.23 on node 7?
Since it's feeding others,
so
I'll now have to add
so it will be 0.23 plus the one for 11 and the one for 6.
Okay. So it will now be node 6 plus node 11 plus what I have at this point to
Thank you so much. Thank you so much.
But node 7 is feeding down to the lowest point, the 13.
But you've added 13 to 6.
Okay, I've added 13 to 6, so
already.
Okay. So which is I will now have 0.73.
What did you get in node 11? What did you get?
No, we got 0.35.
35, okay.
0.35 plus 0.73 plus 0.23. So 0.35 plus 0.73 plus 0.23. Okay, so we now have 1.31 meter per second. Yes, we have 1.31 per second. So are we still using the same slope?
Yes.
Okay, we're using the same slope.
Let's assume the same slope. Good.
So 0.4 slope. So we have manogram 0.4, so around 1.3 1 meter. So we still have 100 mm.
I write it now.
Okay. Okay.
We got 1 point what we got?
1.31.
1.3. Are you sure it's still 100 mm? Yeah, I think this it should still be 100 mm.
Yeah, because it's not, you know,
The value has not gone. The value is still within. It's still within 1.
I think it's 1.5.
But can I tell you that the first one with this 0.753 that we use 100 mm, you know, it's over designed. It's over designed.
Okay.
It's over designed. 75 mm will have worked, but the standard says that is what the standard, because the standard says anything less than 1, you should use 1. But I know.
Yes, same one. Okay. 75 will work. Okay.
Sometimes it will work, but that's the limitation of our chart.
Okay. 75 will work. Then 90, because we also have, I think, 90 something mm for water, for PPR.
Now let's move the other side. We're going to do node 10 and then let's start with node 12. Because for us to get node 9, we need to do node 12 and node 10.
We both get node, okay, 9. Okay, we need to use node 12 and node 10.
Then to get node 8, we need to know node 7 and node 9. So now we have node 7, but we don't have node 9.
We have node 7. This node 7. So it's goes to temperature 1. So we now do node 12, right?
Yes.
So that's street 9 to 12. Street 9 to 12. So 9 to 12. Okay, this will be 9 to 12. 9 to 12. 9 to 12, okay. Okay, this 9 to 12. Now we have how many houses? We have 1, 2, 3, 4, 5, 6, 7, 8. So I can make it 10 houses. If you make it 10 houses, you can still use 0.023, which is we have to 0.23 meter per second. 10 houses, 10 houses, 10 houses. So which means node 12 is equal to 0.23 meter per second. Meter per second. The slope will still be 0.4 slope. So which means the pipe diameter will still be 100. So we need 9 node 8. We have node 7. That's 9 to 8. 10 to 9. 29, node 10 in place. We have node 8 9, 17. So we have this node, okay. So we have 9, 8, we have 6, 7 to 8, 6, 7 to 8. So if you go from Ghana, sometimes he put his mic on mute. Yeah. Maybe so that give you time to work on it. Yeah, maybe somebody. No, it also give you time. So. Yes. So note 12. Okay. Note 12. So if I'm looking for now, I want to note 9 since it's fitted this, I want to get 6 to 8 and 6 to 8. 6 to 8. So node 9 to 8. Streets node 8, which is street 9, 8 to 9, street 8 to 9. Okay, street 8 to 9. Street 8 to 9. 8 to 9 is 8 is 9 to 8. To 8. 6. 8 houses. So 0.023 multiplied by 8, which is going to give me 23 times 8. 0.2 per second. 1.2 per second is to give me a diameter. So for me to get with my 0.2 per second, 0.2 over 0.23 of 1. So so 0.2 plus 2.
Which one are you doing now?
Okay, yeah. You said for us to get node 9,
we need
we have to
10,
node 12 and node
10.
Is it 12 and 10?
Yes, now. Look at
okay,
the tree
not
now.
8. Okay.
No. It is when you want to do node 4, you will now need 8, 5, and 3. When you want to do 8, you will need 9 and look at it now. Now you see those dotted lines. I want you to ignore those dotted lines. They are for looping. I'll tell you what they are later on.
Okay. So the 10 is flowing down to 9.
Everything is flowing from storage tank downwards. So before water will get to 10, it will get to 9 and then divide into 2.
To 12. Okay.
To flow to 12 and to 10.
Okay. I've gotten 12. 12 is 12 is just the same thing, 0.23 because the explained houses are 10.
Then 10, how about 10?
So that's not 10. Let me note 10. In 10 will be street 9, 10. Street 9 or 10 to 9. 10 to 9, which is how many houses? I have okay, I have 1, 2, 3, 4, 5, 6, 7, 8. So the same thing, which is I still have 0.23 meter per second. So my node 9 is equal to node 12 plus node 10. So I have 0.23 plus and node 12 is 0.232. 0.23. So node 9 equals to 0.23 plus 0.23. 0.23 times 2. So 0.46, 0.46 meter per second. So which means my diameter will still be 100. That's 100. So another node. Okay. 0.46. I think this story think this one is coming here. So okay, it's fine. It's 46. Okay. Five. No, 6. 5 to 4. So 6, 5 to 4. 6, 5 to 4. 6, 5. Besides 5 to 4. 6, 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3. So 14. We have 14 multiplied by 0.023. 0.32 meter per second. So 0.232 meter per second, then node, that's node 5. So node 4 will be 8. 4 will be 8. I have a question. Can I ask you? I have a question. Can I ask you? So, something. Okay, I'm going to get node 3 too now. This is node 3. Street. 4 to 3. So 4 to 3. 4 to 3. 4 to 3. So 4 to 3 is 4 to 3. 1. How is that big house? 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll make it 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 plus 9. That's 18. So I'll make it 20. 20. So which is equal to 20 multiplied by 0.023. Hello, sir.
I can hear you.
You're back, right? Sorry, I want to
I'll be
quickly.
here.
Okay, I want to ask you a question, please.
Mm-hmm.
Okay, because since we've calculated for the node 9 that we calculated for is 0.46, which means it's
No, how did you get 0.46 for node 9?
node 12 plus node 10.
What do you got in node 10?
0.23 because it's an estimate of 10 houses.
10 houses, yeah.
10 houses. So, and
so node 9 is what now?
0.46.
Good.
Then if I may understand what you explained the other time, which means for us to get node 4, I have to have node 5 and node 3, right?
And node 8.
Okay, to get node 4.
To get node 4, you need to have node 5, node 3, node 8. To get node 8, you need to have node 7 and node 9.
Okay, so which I have to add node 9 to node 7 for me to get it. Okay.
To get it. Okay. Thank you.
Okay. Okay, that's node 8 now. Node 8 is equals to node 9 plus node 7. And my node 9 is 0.46 plus node 7. Sure. Okay, so 6 plus 11. 7 not 11. So that's 7. Plus 3.7. So point 7 per second. Just a second. Wow. Which means I could change. So you get to 1 point, so we're using 0.4 slope diameter. It's okay, first slope, so 0.8. 0.8. Hello, sir.
I can hear you.
So I just noticed an observation. Since my node 8 is node 9 plus node 7, then so I now went back to, I noticed that my pipe diameter has changed. I don't know if it's correct. I got to 1.8 liter per second.
What did you get?
1.8 liter per second.
For where? For which one?
Node 8.
Yes, about that. You're right.
So I now went back to my node 7 again to refresh from my drawing, since I'm taking my point from sorry, let me go back. I didn't want to ask the question. Since node 7 is node 11 plus 6, right?
Sorry?
I actually want to go back to note 7. How we got note 7 is note
How we
11
got note 7 is that we got the houses that are between 8 and 9, 8 and 7.
Okay.
We got 0.23 or so. We now added it to the value we got in node 11 and the value
Okay,
we got in node
okay, because we had 3. Okay. So
next you're going to get node 3 and node 5.
I've gotten node 3.
No. You've not got node 3 and node 5. You have not gotten them.
Node 3 is street 4 to 3, right?
Eh?
Node 3 is street 4 to 3.
Yes, it's 4 to 3, yes.
Yes, I got 0.46.
That's for node 3, Abi?
Yes.
I write it now. Then for
yes.
node 5.
Is street 5 to 4, right? Or 4 to 5? I got 0.32.
0.32. Right. Therefore, node 4 will be 1.8. Node 4 will now be node 8 plus node 5 plus node 3. What did you get?
Plus node 5 plus node 3. Okay, that will be 0.46 plus 0.8 plus 0.32. So I have 6 plus 0.8 plus 0.32. Okay, I have 1.6.
No, you're wrong. You already have 1 point something in node 8.
No. Okay, sorry, I made a mistake. 1 point, not 0.1. Okay, let me do it again. 1 point. Yeah, there was an error. 0.46 plus 1.8 plus 0.32. Okay, 2.6. 2.6 meter per second. So let me check the pipe size because it will change. I don't know how big that's 2.6. Okay. Can we say our 2.6 is equivalent to 2.5, right?
Yes.
Okay,
2.6.
Okay, we should have like 150 diameter.
Good. Now you're talking. All right, let's get node 2. For you to get node 1, you need to have node 4 and node 2.
Okay, let me. So I'm coming. Let me. Okay. Okay, we should get. Okay, node 2, right? Okay. Okay. Node 2 is just alone since it's flowing from 1 to 2. Street 1 to 2, right? Node 2. 1 to 2. So let me get my point. Okay. 1, 2, 3, 4. My node 2 can still be 0.23. Node 2. So I have node 2. So my node 1. So node 1. Node 1 equals to node 2 plus node 4. Node 4. So my node 4 is 2.6 plus node 2. 0.3. From current, okay, no more ground. So 2.8. 2.8. 150. Just low. No, I think I was once switching off my mic because of my daughter. Well, I got just this is stuff. I think I'm done. Because when you get node 1, you need to get node 1, you need to get node 1, it's node 2 plus 4. That's why I did enjoy design.
Yeah, just came back. Just came back.
So for us to get 7, since 8 is going to 7, F1 plus 8 to 7. For us to get 9, we have to get 9. Okay, 9. Okay, 9. Okay. Topography. Okay. Thank you for bringing me to the office.
Which one are you doing now?
Yes, I have node 2 and node 1. If
No,
I'm correct,
node 1 is simply 4 plus 2 because there are no houses. I don't think there are houses between node 1 and node 4. Unless you want to design for future, what we discussed yesterday. Unless in your wisdom, you know the place and you assume that those people in those areas have not developed their houses. So you can assume houses there. You want to do that?
Okay, node 1 to 4.
Yes, now.
I think we have some things on.
No, nothing. Is there anything? I don't think there's anything.
But we have houses. We have 1, 2, 3,
there is. Okay, you see?
4, 5. So we can explain for 10.
So 10. Yeah, so for 10,
yes. So which will now be node 2 plus node 4 plus what we get from streets 1 to 4, right? Streets 1 to 4 is 0.023 multiplied by 10. So we have 0.23 meter per second. So now this is node 1. So we have node 1 plus 0.23 plus 2.6 plus 0.23. Oh. Yes, I know the pipe will be different. So let's see the justification.
What's the range for pH? That is okay.
It's within 6 point to 8.5 now.
So what is Mark saying? That's acidic, isn't it? The picture is centering.
So okay, maybe I'll ask my.
That's acidic, isn't it? See the picture is centering. Is it acidic?
This picture seems to means with 8. 7 and 8. It's within 7 and 8 now.
Between 7 and 8, I mean? At all.
It's not acidic.
7 and 8 is it acidic?
It's not acidic.
If they put input
Maybe I ask this
input 7.8.
As the
And that's the as you say.
if 7.8 is not acidic now, it's within the range. No, a guru, you have to.
If it's acidic, you will need a dosing system. Can you imagine? To get it up to 7.8. No.
No.
No. No.
Okay, we still need 115. No.
That guy just wants to sell things. I don't think it's after the man will complain of scratching itching.
No,
I don't think
is this now? It's BNL. This is designed for BNL now. This is what about.
okay, sorry. I don't think it's it.
I'm here. Are you?
Yes. I for the node 1, what we got between the streets 1 to 4 plus node 2 and node 4. So I have 3.06 meter per second. The pipe diameter is 150 still together with node 150 together with one at node 4. The same
So
size.
that means the water, the final pipe diameter is 150.
Yes, the one that is taking water from the source, right?
Yeah, so I want you to review what you've done in 5 minutes. And I want you to understand it.
Okay.
Now, you see that 3 point something.
Yes.
If you do backward iteration, you know that, that 3 point something is liter per seconds. If you convert it back to meter cube per day, that becomes the water requirement of that city.
Wow. Okay.
If you backward, you know what I mean? Convert it back to meter cube per day. It will become the water requirement. They ask you what's the flow, what is the water requirement of this district or this area. That becomes the value. And that will also be what you use to design your tank.
Okay.
In the material I sent you, you see tank. Tank requires 3 volume. What we call equalizing volume, volume for firefighting, and then emergency volume.
Okay.
But as a layman, you can use that value to also get idea of what the maximum tank size will be.
Okay. This same 3. Okay.
3.6. If you convert it to liter per day, you know when you say per day means a daily volume.
Volume. Okay.
So you can easily say that this is what these people need in one day.
Okay, liter per day. Okay.
And then if you convert it to meter cube, you can use it as a
tank.
stick. Thank you.
Okay.
But that tank is a daily tank.
Daily tank, both for the 3 volume you talked about, right?
Yeah, it's a daily. No. When I mean a daily tank, it means that tank must be filled daily.
Okay. Because you're saying that I can still get. Okay, the tank must be filled daily with that capacity. Okay.
Thank you.
Okay.
So
but what I'm asking is that
if it's 12-hour tank, you divide it by 2 because 12 hours is half of a day.
Okay, so you can fill it twice.
God bless you.
Okay, so but the question I want to ask is that which means like you were describing 3 volumes, you're talking about the firefighting and other ones.
Yes.
Everything we take from this source.
No, is in your material. But what I mean is that this the volume you get, you've not gotten it actually because I told you have to convert it to meter cube. If you get that volume, you use what we call equalizing volume. Is in the material explained. You take a percentage of this. Like 20% of this would be your emergency volume. No, emergency is like before you start pumping water in your tank, there is a certain amount of water. There's a level that the water has to go before you trigger your pumping.
Yes.
You must not allow the water to be finished completely.
Yes.
Then if it's a place you're designing for water fighting also, it means you also have to factor in some amount of water in case there's outbreak of fire.
Okay.
It's not when they say there's outbreak of fire, somebody will say there's no water in the tank.
Okay. Okay. Okay.
But most of the time, people don't design for firefighting anyway.
Okay. Okay.
But it's important to know, that it's a global standard, even though we don't do it.
Observe it. Okay.
Even though we don't observe it.
Okay. You said you are giving 5 minutes, right?
Or like let 10, which also serve as small break. Just 10 minutes, just review what you've done and then list all the questions you don't understand. And let it be that if I give you such a thing, you can comfortably, there are only 100 houses here, but I can give you a one that contains 1,000 houses. We don't have more than 10 streets here, but I can give you the one that contains 100 streets. You should be able to know how to break them down and then get the water from the last house to the source.
And the sizes?
Yeah, the size of the pipe, thank you, which can only be done by getting the demand for each houses, which goes to the demand in each section, which goes to demand in each subsection, and finally demand coming from the main section. I don't know if you understand what we just did now.
Yes.
This is the same way how current flows. People that are electrical engineers.
Yes.
In mechanical, in civil engineering, this is like a Kirchhoff's law for us.
Kirchhoff, okay. Yes.
For mechanical, I don't know what you guys call it, but I know that engineering is multifaceted.
Interwoven.
So interwoven. And that also is like law of continuity in fluid mechanics.
Okay.
What goes in is what goes out.
Yes.
That 3.6 that is coming per seconds must trigger down the pipes based on the unique demand of each session.
Okay.
The session with the higher number of people will take more water.
Okay.
So take 10 minutes and just review what we've done.
Please, before you go, I want to give a colleague so I want to get an information from you. The first information is the pH of waterboard in Abuja. Please, you have an idea?
They target 7, but what they do is they target 7 at the consumer end, which is neutral. But somebody told me that they keep it alkaline because of with chlorine. They make it to be a little bit above 7.
Above 7, okay.
They make it to be a little bit above 7, maybe 7.5 or so, with the expectation that it will, by the time it gets to the final consumer, it will get to 7.
It will be 7. Okay.
Using carbon hypochlorite also.
Hypochlorite. Okay. Okay. Then secondly, my colleague is here. He wants to ask how we can join so I can pay, and how this thing will be. I don't know. Can you talk with him or?
Okay.
Let me give him the mic.
Okay.
Okay. He's hearing you.
Okay. What will happen is in 2 weeks' time, I think I will organize another session.
Okay.
So it's not left for him. I don't know how you got this information, but he's going to get the same information the same way. But if you feel he wants to pay now, no problem. But in 2 weeks' time, in exactly 2 weeks' time, which is after weekend, because next weekend we'll have another training. So after next weekend, there's going to be another training, same time, same section. So let him program himself for that session.
Okay.
Good evening.
Well, I greet you, sir.
Yeah, thank you. Yeah, I was supposed to join this one, but because we were busy at the office, I couldn't join.
Okay.
Yeah, but is 2 weeks not too far?
Next. It's not only Femi. There's another guy that's supposed to join us today, but
yeah, he told me.
He couldn't make it, and doing training on a weekday is not easy.
Yeah.
It's better we flog. What I could do next week, even to do it Friday, Saturday, Sunday, because I know that churches have not really resumed.
Yes.
But I gave indulgence. Let it be in 2 weeks. But see, I've given him all the materials, and I'm going to send more material for him for the software aspect. I'm going to give him the direction, so you can even learn ahead of time. Let it just be that the training is feel like a refresher for you.
Okay.
I think nothing stops you from learning the basics. Let him give you the whole materials, including the one I'm going to send, and then the software is online, it's open source, So the other guy that also came, I don't know whether that is what kept him. I gave him a lot of materials, asked him to go and read up so I can follow up.
Okay.
Please, I'll just urge you to have that patience.
Okay, but I will get your account details from him.
Oh, okay.
And pay, but in case you have any time within the weekend, or you can let me know.
But what you also do is, I don't know when we will do the software. When I'll put him through the software, that one is absolutely independent of this. You can still join. What we're going to do is software. This diagram that we are working on is just to represent it in software.
Okay.
And run it and then get results and get real-time results.
Okay.
The software is basically for modeling and simulation. It's not for design. Nobody does design. No software does design.
Okay.
But it's to model and then simulate, so you can simulate different scenarios.
Yes.
Yes.
Yeah. Okay.
So somehow I think you can join now with the software aspect. That means in the next class, you can now join you can now do the first principle. But if there's anyhow within next week, I can dedicate the whole day, and you know your timetable.
Okay.
I can squeeze out time and crash it for you one day.
Okay.
A more extended period.
Okay.
But you can join now if you have time. Like if it's tomorrow, we're going to do the software.
Okay. So he will show me. Is there anything I need to put on my system or his?
Yes, I'll show you the direction where to download the software.
Okay, he knows already.
No, he doesn't know yet that one. I'll send it now. I'll send it before the end of this training.
Okay.
I'll send him the manual and a small exercise and where to download the software and installed. And then you will now do a small tutorial that will bring him up to speed. Then tomorrow, what we need to do is to model what we are doing today.
Okay.
Exactly what you have is what we're going
to what you suggested, I think is okay. Let me not be too anxious, and then at the end of the day, it's better that since, like you said, I should read up the material, and prepare myself, so that by the time we're getting to weekend, at least I would have had a good knowledge of it, because I didn't join from the onset.
Yeah, you didn't join yesterday.
No. He sent it to me last week.
Okay.
But we were supposed to start together. Even though the day he called you that he was going to make payment, that we were together, but there are some things in the office we needed to clear. So two of us cannot be out at the same time.
No problem.
That was why he started before me.
In fact, if I can give you my word, if you read the whole software and do the what we are doing, if you read the test, and then you were able to follow up with the software application.
Okay.
As soon as you're done with reading it, just let me know. I'll cover our time and then teach you what I taught him today, and then try what I did. What we did yesterday was even the foundation itself. It was more like introduction.
So I've told him now he's going to be my teacher. Anyone I don't understand, whatever he understands, he will explain. Then when you
are done and you're ready, just call me. I will strike out one day.
All right, no problem.
Even before that 2 weeks time, but 2 weeks time, I'm very sure.
All right, no problem.
It's all right, sir.
Thank you.
All right.
I'm handing over back to him.
Okay, sir.
Hello. Okay, so I'll go for the break now, right?
Yes, 10 minutes.
Okay.
Thank you.
You guys are still continuing.
No, we're running up. But it's giving me 10 minutes break to go through what I've done. Any question? Yeah.
So you see, thank you.
Thank you.
Oh, okay.
No.
Okay. I'll hold on Nasir for now. Sure, we're not doing Nasir for now. Or are you still going further?
Because if you do Nasir, we have to be committed to the Nasir. So
let's not pack too
and that's why, if you notice why I noticed
that you quite low on Nasir because of
me. What I'm happy is that my people are doing it,
yes.
Which is very important, because this is that we are engaged. And I'm just believing God that if you can sort out how we can get tractor and some kind of farm that they can finance, just do it together.
That's why, since we're doing this farming now, and And since the family there's land available for purchase. So what I think we should do is, seriously speaking,
we want to look at what agriculture is that we attract loan.
Yeah. So this one now.
But they don't pay for buy of land. You have to rent.
Huh?
You have to rent.
You can buy it and then rent from us now. You don't
no problem. No.
What I'm trying to say, let's use this farming now to secure a land there.
That's why.
That from the process, we'll take from it, buy a land, then the remaining.
That's what we need to do now is to brainstorm on how we can facilitate a loan that will be able to finance
the tractor.
The
tractor is a strong one.
But I'm not still looking for the commercial viability of the tractor more.
Well,
so I want to bring it.
Even in tractor is very viable.
I'm seeing us collecting no less than 2 tractors. If it's possible, me I'll collect one. If they can't give us at once, because loan is two-faced. You can between producing while the chain value, somebody can come in. So just put into 2.
Okay, so we just take the 2.
Just take the 2. But we are pretty on
that. So that we can now help us buy 2. While giving us time.
To we know that we can be paying. By the time this business starts coming up, we can be using to be servicing. I don't know if it's so just for us to. So that's why I've noticed. After like I told you, even that piggery now, I'm not going to collect any facility for it. If that guy is going to start, you can just do any amount you can give that we finance it. Even if she can bring her money, without how many pigs. Like my mom now, she's telling me that our goat has really plenty. I worked for Shitty before.
How many are there now?
She was counting that day, but the story she was saying, my mind was.
Did she count up to 5?
No, what they do is before they will bring goat for her. She will take care of it. Then maybe if you could give pets, she should take from it, then give her head. But now she
has her own.
And she has gotten plenty now. And
they roam about?
No, don't allow go to roam about them. She just put them within she feeds them. Like this, my wife just and I did been
and that's another
I travel routine. I'll just be going to
that's another business.
But that won't go to different from our goat.
Are they bigger?
They're the short goat. But I did been but they have me too. And they have their market there. I did we've finished that place for them. I'll bring the breed of this one.
Okay.
Take it there.
Okay, so that I can mix it.
Exactly. So, but yeah, once we have a farmland here and we fence it, we can do animals as well. They can give you loan too for fattening of cows, fattening of animals.
Yeah. I have a friend who
so
he targets Christmas time and
this guy give me 10 minutes, so let me go and his myself. So you see that our commitment can't be the same like others. So that's why and some have to share some things and concentrate on what you have, because now we are developing this water side very well.
Yeah. Then another thing that we need to it's just that can't go for everything. Another thing we need to do, like on Saturday next week, if we have to go to the farm to go and check what they've done, I will leave the house early, even before they wake up.
But today we are fast. Because last week it was by this time we started.
I know.
And we didn't leave home on time.
I know, but if I had come earlier, I would have been faster.
Faster, I will be here early.
Yes. So what I will do, because see,
but that food we ate was necessary.
No, it was necessary. Because as it is now, yes, I'll go home with you.
You go? Okay.
Carry Kimo lock the.
Right. Even if you sleep, I know that sleep was not really. No, like I do mistake yesterday, I just let it on sleep. I forgot to do
it. There's something we need to do. But when I come with you tomorrow, you know this budget.